In this example, we're going to use DFM concurrent costing to analyze a machined block. We can see a drawing here on the screen of the block we're going to analyze, and it's got dimensions of 4 by 2.5 by 2. And we can see it's got a slot milled through it here that's 3/4 by 2.5, half-inch deep. It's going to be finished face milled on the top, and we're going to have to grind this 16 micro-inch finish into the bottom. So if we were to do a machining analysis of that, we would start out here calling this part the block. We could give it a part number, and maybe we want to make 1,000 of these parts. We're going to put in the envelope dimensions. It's 2 inches tall, it's 2.5 inches wide, it's 4 inches long, and it's got an average thickness of 2 inches. The forming direction for a machined part is through the length of the long axis, so we'll pick X as the forming direction. I'll select a process and a material, which will load the material database. And from there, I'm going to pick under machined cut from stock, the machined cut from stock option. And under carbon steel, I'll pick a generic low carbon steel. Assuming that everything's okay, I've got two things that are green here. I'm going to say okay. And I'll get some information right away about the cost of the workpiece. $3.04 to have that section cut off using the default choice here of the abrasive cutoff machine. Now, new in concurrent costing version 2.3 is the addition of the machining quick estimator, and a separate tutorial will be available on our website www.dfma.com that'll walk you through how to do this same analysis using the quick estimator. Here we want to make sure that the default choices for the stock form of the material and the cutoff method are okay. I'm going to accept both of those as being correct at this point. And now I need to add the machine tools on which I'm going to do the machining operations. So I right-click here on the process tree. I choose Insert Machine Tool Setup. And the first thing I'm going to do is put this thing on a vertical machining center. I'm going to pick this Haas machine here and select Add. It transfers that machine's data onto the tree for me. I can close the library window. And now I can go about changing the work holding device. So in this case, we'll go ahead and allow this part to be placed into a horizontal fixture. And if I have it set up that way, then I don't need to reclamp this in order to do any of the machining. I can do it all in one orientation, so I don't have any reversals of the workpiece. So now I need to build up the list of steps that are going to be involved in the machining of this piece. So I right-click on the tree, I choose Insert Operation, and under the machining category here, I need to pick what it is I'm going to do. Well, the first operation is going to be a finish face milling operation across the top. Then under miscellaneous operations here, I'm going to do a center drilling operation. So we'll do multiple center drills. Then we are going to, under the drilling option here, drill multiple holes. And then under tapping, we're going to tap multiple holes. They happen to be UNC holes, if we were to look at the drawing again. And then I need to mill that slot. So under slot milling here, we need to do a rough and finish slot milling operation. So I'll choose Add, and it'll put that onto the tree for me. I could have also chosen the slot milling operation from down in this area as well. So that'll round out the list of operations that need to be carried out on this particular setup. So now I need to just go back and supply the dimensions. So for the finish facing operation, that's going to have a dimension of 2.5 by 4 inches, and we can relax the surface finish requirement here. Note on the drawing it was 250 micro inches. Then we're going to center drill those two holes. The diameter of the center drill, let's say, is 1 inch. We're going to do 2 of them, and we're going to drill them one at a time. Those 2 holes that we're going to drill are 0.201 in diameter, and they are 3/4 of an inch deep. And then we're going to tap those 201 diameter holes a 1/2 inch deep. And then finally, the slot milling operation. The width of the slot is 0.75. The length of the slot is 2.5, and the depth of material we're going to remove is 0.5 inches. Now if I click Calculate, and I could have done that at any one of the operation levels, I'll see the results for that particular operation. So in this case, the slot is going to take 45 seconds and cost me 51 cents at the rate for the machine. I can step my way up through the operations that I've added, seeing the costs and times at each stage of the way, Or I can select at the machine tool level and see that I've got 149.5 seconds of machining time, which is going to cost me $1.92. Now, to achieve that 16 micro-inch finish that was in the bottom of that slot, we need to now insert a second machine tool setup. So I'll choose Insert Machine Tool Setup again. And under Grinding Machines, I'm going to add a generic horizontal spindle surface grinder. We'll add that to the tree. It puts that on the list from where we can choose the work holding device. We'll go ahead and clamp this on the magnetic table. And then I need to insert an operation to do the grinding. So under grinding, I want to do a horizontal surface traverse grinding operation. I'll hit add to put that on the tree. And now I need to specify again the dimensions of the feature. So the width of the ground surface was 0.75, and the length of the ground surface is 2.5 inches. And then the amount of stock we're going to remove, let's say we're going to remove, we would have left maybe 10, let's even go 5 thousandths of material. Let's do 10 thousandths of material on the bottom of that slot. And if I click calculate, we can see the time associated with that material removal for the ground feature. And it's also recalculating the rest of the operations on the tree for us here. So now I have the time and cost of my grinding operation, the time and cost of my let's call them rough machining operations that were being carried out on the Haas machine here. This line item represents the cost of the workpiece, and then all the way up here at the top, $5.94 represents the cost of this part fully machined. Now we could have used the operations in the operations library to include finishing operations if we needed to break the edges or to finish the part or inspect it in some way. And all of those things would be rolled into the total, and then I could use the reporting features available from DFM to communicate these results with other members of my team.